Let's look at revision of high school mathematics past exam papers. We are looking at a topic that is known as probability, and we are looking at the following high school maths levels. Without wasting time, let's quickly rush to our chosen past exam question. The teacher will read, a bag contains 10 buttons that are identical except for color. 7 of the buttons are red and 3 are blue. 2 buttons are drawn at random, one after the other without replacement. So this means this is probability without replacement. Let's quickly rush to our question. Our first question says, complete the tree diagram. Complete the tree diagram. What are we completing here? There are missing probabilities on these arms. Missing probabilities, right? Take note with the 2 arms, the one that is going up and the one that is going down, right? And I'll start by this one which goes up. This arm which goes up implies that we are supposed to find other probabilities that follow. Our first choice being a red button. This simply means the first button to be chosen is red, right? And take note, this is probability without replacement. So the first button which was chosen, which is red, has been set aside. So it means we no longer have 7 red buttons, but we now have 6 red buttons and 3 blue buttons. So probability of getting a red button is 6/9. Which is what they've given us here. And obviously, this one is easy. Probability of getting a blue button. The blue buttons have not been touched. So the number remains 3/9. Because the first one to be chosen was red. This is fairly easy. We are done with the arm that goes up. Let's look at this one which goes down. Right? This one implies that the first button to be chosen is blue. What are the probabilities for the second choices? If the first button to be chosen is blue in a bag of 10 buttons, right? It means we no longer have 3 buttons when we're looking at our second choice or our second buttons. If the first one chosen is blue, what is the probability of picking a second one being blue? If the first one is blue and this blue button has been set aside, it means we no longer have 3 blue buttons, but we now have 2. So the probability of getting a second one being a blue button is 2/9. Right? In the same vein, probability of getting a red button, given that the first one set aside is blue, the number of red buttons remain untouched. They remain the same. It's 7. Probability 7/9. This is fairly easy. We have written all the information that was required of us. Writing the missing probabilities. This is what. Let's proceed to the next question. It says, find the probability that both buttons are red. Both buttons are red. This is red. This is red, right? So we can safely say here we get red, red. And let's work the related probabilities, which is what? 7/10 multiplied by 6/9, which will give us 42/90, which is 7/15 when reduced to its lowest terms. So I can safely answer my question, which is question 5C. Question 5C, part 2, probability of getting red, red is equals to 7/15. This is the answer that we got here. I'll proceed to part 3 of our question. What does part 3 of our question say? It says, find the probability that at least one of the button is red. There's a key word here, at least. The word at least in probability means minimum. I can rephrase the question and it will say, find the probability of getting a minimum of one red button. A minimum of one red button. When we are told of a minimum of one red button, it means when we see one red button, we will take that choice. When we see two red buttons, we pick that choice. When we see three red buttons, we pick that choice. Why? We've been given the minimum, but not the maximum. I'll proceed. Here, what do we have? We have red followed by blue. Right? We have red, I'll write in red. We have red. Right? We have red followed by blue. Right? And what is the probability? It's 7 over 10 multiplied by 3 over 9, which is 21 over what? 90, which is 7 over 10. Right? Let's proceed. What combination do we have here? We have this blue here followed by this red. And what are the probabilities? I'll proceed. Probabilities are 3 over 10, which is this, multiplied by 7 over 9. This will give us 21 over 90, which when reduced will give us 7 over what? 10. What combination do we have here? We're going to have blue followed by blue. This combination we don't want. It contains blue only. There is no red. Right? We're going to select only combinations that contain minimum of one red. Right? Meaning to say, where we're going to find the two red balls like here, we'll take the probability. Add on to this probability and add on to this probability. Right? We are adding all probabilities that contain minimum of one red button. And in my choices, I'm going to pick the following fractions as I add probabilities, right? Here we have two red. I will take this, I will take this, and this one. Right? In my selection of fractions, I've chosen fractions that have common denominators. It's easy to add fractions that share common denominators. So I'll calculate my probability. It says probability of getting at least one red, or minimum of one red. What do we get? Probability here, we said we'll get two red, so we'll get the probability. It's 42 over 90. Plus, we get this combination with at least one red. What is the probability? 21 over 90. Plus this combination, which contains one red. What is the probability? It's 21 over 90. If we add this, we get 84 over 90. Right? But we simplify our answer. When this fraction is reduced to its lowest terms, we get 14 over 15. This is our answer. This is fairly easy. So take note, whenever there is a mention of the word at least, it simply means minimum. And minimum, we don't have a maximum. Wherever you find one red ball, you're going to take that. Right? Can you easily follow the teacher's example and answer the following questions? Thank you very much. Have a good day.